Okay, welcome back to my video, dear student. Today we will continue chemistry form 4 chapter 4. Today we will cover two subtopic 4.1 and 4.2. So the title for chapter 4 is the periodic tables of element, jadual berkala unsur. Okay, so 1 Thessalonians 5 verse 16 to 18. Rejoice always, pray without ceasing, give thanks in all circumstances, for this is the will of God in Christ Jesus for you. Okay, so the first one, 4.1, the developments of periodic tables of elements. So at the end of this lesson, you are able to describe the historical developments of the periodic tables of element and also deduce the basic principles of arrangements of elements in the periodic table of elements. So what is periodic tables of element, jadwal berkala unsur? So this table or periodic tables of element classifies known chemical elements in a table according to certain characteristic. Okay, dia akan mengelaskan unsur-unsur yang diketahui ke dalam satu jadual bergantung kepada ciri-ciri yang tertentu. So there are many theories explained by scientists before the modern periodic tables of element. So what is the modern periodic table? The modern periodic table is the periodic table that we use today. Okay, so there are some scientists involved in the developments of the periodic table. So the first one is Antoine Lavoisier. Lavoisier, dia classified elements according to certain groups such as gases, non-metals, metals, metal oxides. Okay, so however, his classification was less accurate because he also classified light, heat, and a few compounds into the group as the elements. So this is less accurate. Besides, there were several elements that were classified into the same group but showed different chemical properties. Okay, the second one is Johann W. Dobereiner. So Dobereiner found that the atomic mass of strontium atom was similar to the average mass of calcium atom and barium atom. Okay, itu adalah penemuan Johann Dobereiner. Dia menemukan bahawa the average mass of calcium atom dengan barium atom adalah sama dengan the atomic mass of strontium atom. Okay, so these elements had the same chemical properties. Okay, so a similar condition occur with chlorine, bromine, iodine. So the group consists of these three elements was named triad. Okay, however, Dobereiner classification was only limited to several elements only. But still, his classification showed the relationship between chemical properties of the elements and also the atomic mass. And then comes to John Newlands. John Newlands, dia arrange elements according to their increasing atomic masses. He arranged 7 elements in a row. Okay, because he found that the chemical and physical properties of the first element recurred at every 8 element. So dia susun elemen 1 sampai elemen ke-7 itu dia susun dalam satu row. Kemudian dia dapati bahawa setiap elemen yang ke-8 dia punya karakteristik akan berulang, recurred at every 8 element. Okay, so he named the arrangements of the law of octaves. Ini dia law of octaves. Okay, the law of octaves had only been confirmed by the first 17 elements only. However, the recurrence in properties of the 8th element showed the presence of periodic pattern in the properties of elements. Okay, so ini adalah permulaan kepada jadual berkala unsur ataupun periodic table yang kita gunakan pada sekarang. Okay. Kemudian kita ada Lothar-Meyer. Meyer plotted the graph of atomic volume against atomic masses of element. So dia plot graph atomic volume against atomic masses. So what he found that the elements at equivalent positions on the curve of the graph had similar chemical properties. For example, referring to the alkali metals such as lithium, sodium, potassium, and rubidium that were located at the peaks of the curve. Mayer also proved the recurrence in properties of elements similar to Newlands. Maksudnya di sini, unsur-unsur yang mempunyai kedudukan atau lokasi yang sama pada graf tersebut mempunyai chemical properties, ciri-ciri kimia yang sama. Contohnya di sini, kalau kita ada beberapa peak di sini, unsur-unsur yang terletak di lokasi yang sama atau peak yang sama ini mempunyai chemical properties yang sama. Begitu penemuan Lodemeyer. Okay? So next one is Dmitry Mendeleev. Mendeleev arranged the elements according to their increasing atomic masses. Only elements with similar chemical properties were arranged in the same vertical column. Okay, vertical column. He had left several empty spaces in his periodic table to be filled by the elements, yet to be discovered. He was successful in predicting the properties of undiscovered element based on the properties of element located above and below an element in the table. Meaning, dia akan menyusun setiap unsur-unsur itu di dalam satu kolom yang sama. Okey, contoh di sini kita ada kolom 1, okey, kita ada kolom 2, kemudian kita ada kolom ketiga. So, unsur-unsur yang berada di kolom pertama, kolom kedua, kolom ketiga itu masing-masing mempunyai ciri-ciri kimia yang sama. Okey, so itu adalah cara penyusunan Dmitry Mendeleev. Kemudian kita ada Henry Moseley. Moseley dia studied frequencies of X-ray released by various elements and eventually found a relationship between the X-ray spectrum and also the proton number. Okay, he proposed that each element ought to have its own proton number. Then he arranged the elements in periodic table of elements according to the increasing proton numbers. Moseley also left empty spaces in his periodic table like Dmitry Mendeleev and successfully predicted 4 elements, namely technetium Tc, promethium Pm, hafnium Hf, and rhenium Re, which were discovered later. So di sini Moseley ini dia menyusun unsur-unsur itu mengikut apa? Mengikut proton, increasing proton number, according to the increasing proton number. Alright? So, itu adalah saintis-saintis yang terlibat di dalam sejarah perkembangan periodic table. Okay? So, basic principles of arrangements of element in periodic table of element. Elements in the periodic tables of elements are arranged in ascending order of proton number. So, you must remember this one. Ascending or increasing proton number. So, ranging from 1 until 118. Okay? Penyusunan unsur-unsur di dalam periodic table itu adalah berdasarkan ascending order of the proton number ataupun increasing proton number. Okay? Elements with similar chemical properties are placed in the same vertical column. Setiap unsur yang mempunyai sama ciri-ciri kimia, dia akan terletak pada kolom yang sama. Okay? So several new elements which were discovered such as rhenium, NH, moscovium, tennessine, and oganesson were added into period 7 of the periodic tables of element. Okay, so ini 1, 2, 3, 4. Keempat-empat ini adalah unsur-unsur baru yang dijumpai Okay, dijumpai. Dan nama-nama ini adalah name after the location ataupun name of the scientist sendirilah. Okay, so we have nihonium, muscovium, tennessine, and also oganesson. Di sini new elements found, right? So the arrangements of periodic tables of element. So you will be able to describe briefly the modern periodic tables of element and also generalize relationship between proton number and the positions of element in the periodic tables of element. Okay, so the modern periodic tables of element is a form of systematic classifications of element in ascending order of proton number from left to the right and from top to the bottom. Okay, the arrangements of element is discussed from the aspect of groups, periods, the proton number, and also the electron arrangement. The vertical column in the periodic tables of elements are called group. Okay, the vertical column, this one is vertical lah. Yang vertical itu kita panggil group. Okay, groups. So there are 18 groups in periodic tables of elements. The number of valence electron pula, number of valence electron will determine the positions of the group of the element. So remember, when we want to determine the positions of the element in which group, so we will refer to dia punya valence electron. Okay, so remember this one, element with 1 or 2 valence electron. Okay, we can determine the group by looking at the number of valence electron. Okay, while element with 3 until 8 valence electron, we determine the group by adding the number of valence electron you add with 10. Okay, you add with 10. For example, we have lithium here. Lithium, the proton number of lithium is 3. Okay, so the electron number is also 3. The electron arrangement is 2.1. So this is the valence electron, 1 valence electron. So dia group 1. Okay, right? So remember, the valence electron refer to dia punya location atau group in the periodic table. But when the element have 3 to 8 valence electron, you need to add 10 to the number of valence electron to determine the group. Okay, for example, here aluminium, proton number 13, so electron number, the number of electron also 13. So electron arrangement is 2, 8, 3. So 3 is the valence electron. So 3. So you need to add 10. Okay, need to add 10. 10 plus 3. So dia berada pada group 13. Okay, group 13. Alright. So itu adalah vertical column. Vertical column. How about the horizontal row? The horizontal row in the periodic tables are called periods. Okay, so there are 7 periods in the periodic tables of elements. The number of shells filled with electrons will determine the positions of element in a period. So kalau kita mau menentukan period sesuatu unsur itu di dalam periodic table, kita lihat kepada dia punya number of shells filled with electrons. Okay, so contohnya tadi lithium di sini, lithium. So proton number 3, so electron arrangement dia 2, 1. Berapa shell yang mengandungi elektron? Kita ada 2, 1 dan 2. So dia berada pada period kedua. Okay, another example, calcium. calcium, proton number 20. So this is the electron arrangement 2882. So dia ada 4 number of shells filled with electron. So dia terletak pada period number 4. Okay, period number 4. Silicon, proton number 14. Electron arrangement is 284. So here valence electron 4. So 4 plus 10 dia berada pada group 14. Okay, and then dia ada 1, 2, 3 shells filled with electron. So dia juga terletak pada period 3. Okay, period 3. Silicon, period 3. Nitrogen, proton number 7. So electron arrangement dia adalah 2, 5. So 2, 5, valence electron dia 5. So 5 plus 10, so 15. So dia berada di group 15. And number of shell filled with electron dia ada 2. So dia terletak pada period kedua. Okay, begitu juga seterusnya. For example, the last example here, krypton. Krypton, proton number dia 36. So arrangement dia adalah 2, 8, 18, 8. So valence electron dia 8. So kita tambah 8 dengan 10 menjadi 18. So dia berada pada group ke-18. The number of shells filled with electron dia ada 1, 2, 3, 4. So oleh itu dia berada pada period ke-4. Okay, so always remember when the question asks you to determine the positions of one element, okay, you need to tell the group and also the period. Okay, group and also period, di mana unsur itu berada, di group keberapa dan di period keberapa. Okay, sentiasa ingat apabila soalan mengatakan predict the location or the positions of this element, so jangan bagi tahu dia hanya berada di group keberapa. No, you must tell also period keberapa, group keberapa. Okay, okay. So kalau group keberapa, macam mana kita tahu? Kita lihat kepada dia punya valence electron. Manakala period itu adalah kita lihat kepada number of shells filled with electrons. Okay, so that's all for today. Okay, I repeat 1 Thessalonians 5 verse 16 to 18. Rejoice always, pray without ceasing, give thanks in all circumstances, for this is the will of God in Christ Jesus for you. Thank you.